Hello all, and welcome back to the Mark Chi School for kids who can't code good and want to learn to do other things good too. Today, I'm asking a big question. But it's a question that I think is quite interesting and one worth looking at, especially if you're just starting out with computing and you're starting out with coding, you've never done anything before, and you've never really delved into what your computer is or how it works at a kind of a detailed level. I'm not going to go into the full-on nuts and bolts level of detail, but I still want to talk about how a computer works and what our interaction is going to be with it if we're going to learn about how to code or how to program a computer. I should talk about how this relates to the previous episode. So I talked in a previous episode, it was all about this kind of technical setup and stuff like that. That's why that one was called episode 0, and this is actually episode 1. So this is actually kind of the first episode in my Getting Started series, because this is the first one where I'm actually teaching you something important, which is just what even is programming and how it works. So let's get into it. So the first thing I'm going to do when we're going to ask what programming is, I'm going to go down into the one tool we're going to be using when we're programming. So it doesn't matter what other stuff we're doing. If we're programming, we're pretty much always going to be using a computer. So I need to ask this question: what is a computer? And I know that's a very silly question from a certain perspective, because I've obviously got one sitting right here in front of me. Carry one around every day, that kind of thing. Computers are things that we very much take for granted, but we don't think about them often in terms of what they are for what we're going to use them for, because they've already been tailor-made to do so many really interesting things. You can, watch a whole bunch of TV on it. Or you can hop on Instagram and TikTok and get a window into all these other people's lives and stuff like that. But all of these applications that are in use in computers have been created by people. And they've been created in that way because of the capabilities of computers. So we can think of a computer as a machine or a tool, as in an object that is capable of carrying out tasks of some kind. Now, that's a very complicated thing to say for a computer, but if I was to show you, just looking for tools on my desk, because I've always got a lot of tools on my desk, here is a paintbrush. Paintbrush is designed for a specific purpose. It's designed to get paints, put them on objects. So it has a simple purpose in life, and it can't be used for many things other than that. I could use it to, brush the dust off a very small object. Or I could use it to put glazes on food or something like that. There are a couple of things you can do with a paintbrush that aren't just painting. But it doesn't have the same kind of variability and, dare I say the word, reprogrammability that a computer has. So the computer can be configured to do many, many different tasks in many, many different ways. They're still limited in terms of what they could do physically, because I can't actually program a computer to paint something. We can do a lot of stuff with AI art and things, but it can't really, I guess if you get a robot arm and attach it to it, you can pick up the paintbrush and start painting. But computers are used for much more abstract tasks, things like calculation, things like simulation, and stuff like that. Fundamentally, at the most basic level, the computer consists of two parts. And I'm really, really kind of hand-waving aside a lot of the technical details here, because what I want for us to put together is a mental model of the computer. One is the thinking part, and the other part is the remembering part. If we only have those two fundamental parts of the computer, that is enough to understand a lot of what we're going to do with programming. So the thinking part is the processor. You buy a computer, you might look at the CPU on a processor, your Intel i7s or whatever, your AMD Ryzens, that kind of thing. That is the part that is going to take information that's given to it, process it in some way, spit information back out. I'm being really vague with my terms here because there are so many possibilities for what computers can do that it's really open still. The memory is the remembering part, and there's actually lots of different kinds of remembering part in our computer, because when I say memory, you might think of RAM, like RAM chips. You put like 16 gigabytes of RAM in your computer, and that's like the memory that you're going to be working with. You're going to be putting programs in and doing stuff. But you could consider your disk drives to be another form of memory, just longer term storage. And even your processor has memory on it, which is its cache and stuff like that. This is basically anywhere we can put information that we're in the middle of processing, or we're going to process soon, or we have already processed and we've now saved. The computer's really going to be going back and forth between those things, either remembering things or processing things, and then those will be intertwined. A lot of the things that we're going to be doing in programming is going to be using either of those things. Either we're going to be making changes to information, or we're going to be storing information in one way or another. So what is programming? I have said the term programming, and I've said that we're going to be doing it, but I have not really defined exactly what that is. You may have heard a lot about it before, but for anyone who is not familiar with it, I want to talk through some of the basics. So I like to compare programming to talking to your computer, and I know that's not really something we can definitely do. I mean, sure, I can talk to my computer. I'm literally talking to my computer right now. I'm looking at my webcam and talking to it while I've got my slides up, and I'm like, using slides to remind me what to say. But is the computer understanding what I'm saying right now, or is it just digitizing it in a way that I can then upload to YouTube and then send out to you out there in the world? So I guess there are, you get your Siri and your Alexa and your OK Google and all that kind of stuff. You can talk to your computer in that way, and you can get some stuff out of it. But when we're talking to our computers, when I'm talking about programming with our computers, it's a much deeper connection that we're getting with our computer. So one of the things we need to do to be able to communicate with our computer, and the computer doesn't understand English, the language I'm speaking. I don't necessarily understand exactly all the numbers that are going through a computer processor. So we need a kind of a shared language, something that a human can understand, but a computer can also process. And those things are called programming languages. I'm just about to talk about them in the next slide that I've got here. But the other thing that we need to understand is if we're going to try to communicate with our computer, they are machines, we are humans. We have this soft, fleshy brain, mostly water. You put water in the computer, bad things happen to it. I mean, you can water cool them. There's a bit of water in the computer nowadays, but they don't tend to work on water. Most of the thinking bits on the computer are dry. Is silicon dry? Yes, I think silicon's technically dry. The interesting thing about computers is they're not really going to be with us all the way in a lot of the ways that we think and like to communicate. So they don't understand the human context. I might say to a computer that I can move my hand or something. The computer doesn't necessarily have any background knowledge to understand what a hand is, or that a human has muscles and we can have all this physical interaction with the world. Nor are we going to be able to convey the same kind of things we do via, connotations or implication or sarcasm or all these kinds of things that are part of human communication. We can't necessarily rely on our computer to understand that. So what we need then are these things called programming languages. And we use programming languages to have this communication with our computers. But in order for us to do this, it needs to be a language that we can partially understand, the computer can partially understand, and both of us can work on this together. So it can't necessarily be as open as a human spoken language. So programming languages tend to be highly specific, logical languages with highly specific grammar and their own kind of context. They will likely have no ambiguity as well, so you cannot tell the computer something in a programming language and have it possibly take a different meaning. Everything has a kind of a fixed meaning in a programming language. So as I was saying, these things are logical, these languages. They're not designed for us to tell a story. They're usually designed for us to describe a procedure we would like the computer to carry out, or to specify a particular task that needs to be done. There are a lot of programming languages in the world. I've listed a bunch of them down here. Some of them are in here because they're very popular. Some of them are in here because they're historically significant. Some of them are in here just for fun as well. But these are a lot of the languages that are in the world today, but there's so many. I would not think to count how many programming languages exist. But fundamentally, they all serve this same purpose, which is to bridge a gap between a human and a computer and allow us to do what I said at the beginning, which was that a computer is a highly configurable tool that can be used for many different purposes. The programming language allows us to give the computer its different purposes. So, we have a computer. We have the idea that we have a language that we can share. And then we can say, okay, what are we going to write in that language? Programming languages are written? Typed. I mean, you can handwrite them if you want, but the computer's going to have a lot of trouble reading them if they're handwritten. So a computer program is something that we would create, something that a human usually would create. I mean, computers can create computer programs themselves to a certain extent, but a lot of the time, if we have an intention for what we would like the computer to do, we have to write the program ourselves. So a lot of the time, I like to describe a computer program like it's a recipe. So if you do cooking and you're going to follow a recipe, you would have your ingredients and you have your step-by-step process. You know, cut something up, mix some things together, put it in the oven at a certain temperature for a certain amount of time, get it back out. You know, it's a sequence of instructions that are going to get carried out one after the other. Things can get more complicated. You can be frying something while something else is in the oven. Computers can do that too. They can think about multiple things at the same time. But in the simplest case, we give the computer a series of instructions one after the other, and they carry them out one at a time. And then they will follow the sequence of instructions, and they will hopefully reach the goal that we wanted them to do. Computers are very precise and unquestioning machines, so they will do exactly what you tell them to do regardless of whether what you told them to do was correct or not, regardless of whether what you told them to do is going to reach the goals that you wanted or not, because unless we can really give the computer the exact path to reach our goal, they don't know what our goal is and they can't reach it for us. I mean, as I say this, you know, technology is advancing to the point where there are many times with AI development that's happening nowadays that there are things the computer can second guess us on and do quite well at that. But we're still in this kind of middle period of the whole kind of development of computer programming where we're still writing stuff very specifically ourselves as humans and not necessarily having computers write all the programs or anything like that. But I think we are actually approaching a time over the next couple of decades maybe where computers writing their own programs are going to get better and better. But, you know, we'll watch this space and see what happens, right? The trick really is there is no reason why the computer understands our intentions or our goals. It'll only understand our instructions. So we need to give them the right instructions so that they do the right thing. And that is one of the core elements of what I would consider what learning how to program computers is. So, what are we going to learn in this course? So this is a getting started course where I'm going to teach people how to work with Python. And we've got this kind of goal, this kind of project that we're working on. I'm slowly going to build up, which is a sort of a Dungeons and Dragons simulator. It's a really, really simplified version of it. It's not going to be able to do everything that happens in a game, but in working on this project, we're going to learn things like the basic syntax and grammar of one particular programming language. I do find that once you've learned one language, hopping onto another language is not super hard. A lot of the things that programming languages do were designed by the same people who knew other programming languages. So it's not like, say, the difference for me as an English speaker, the difference between learning to write in Chinese versus learning to write in, say, French. The letters are different, the grammar is different, and things are very, very different in those languages. I find that programming languages tend to be much closer to each other in their operation than spoken languages. So you'll actually find that once you learn one programming language, it's easy to jump between things, because learning the languages is actually only a small part of programming in general. A lot of the other things that we're going to learn in programming are how to solve problems, how to logically solve problems. Because when we're trying to create computing solutions to problems, we're trying to phrase the problems that we can see and try to solve in a way that we know that the computer can understand. So it's like this idea that we have an issue we're trying to tackle. We use our human logic to come up with an idea of how we're going to do that. Once we've got that idea, we then translate that into something that we think is machine understandable and machine executable. And then we will write that down in the code using the correct syntax and grammar. So that's the process that I want to be able to teach people, and I will be teaching you as I go through different little problems. I'm going to set up problems, show partially how to do them, give people challenges to try to do more. And also some of the tricks. So we're not just going to have to solve every problem from scratch. There are things that are called data structures and other techniques and stuff like that that exist in programming and are kind of well known. A lot of computer programming is taken from a lot of abstract mathematics, in a sense, and logical mathematics. And so we've kind of co-opted a lot of the things that mathematicians put a whole lot of work into discovering, and we tend to use those things to do whatever we need to do. So I'm going to show you a bunch of that stuff over the next few months as we go through this, but I wanted to do this introduction so that the fundamental concepts of, what is a computer and what is programming and stuff like that are kind of laid down first. So we have ourselves a shared language. So things I've told you about now are easy for you to understand later. So I'll leave the video there, but I've got another slide here of just like more details and stuff. So if you want to know more, I have started a Patreon. The link is here. The link will be in the description of this video as well. On the Patreon, there are documents to go alongside some of the videos that I've done. So my episode 0 video has a document in there, which is like a really detailed guide on how to set up your computer for coding in Python. Once I start coding, there will be source code there to download. So, I mean, if you're watching the videos while I'm coding, you could literally type in everything I'm typing in, but if you want to, you can also grab the source code from the Patreon. And also there's Discord there, so you can ask me questions if you need to. I've got a link here on the slide, but also I'll put the link in the description because it's, I think, much easier to click on it because I don't think you can really click it in the video. I also do one-on-one tutoring. I do have a bunch of students already, but depending on when you watch this video, I may have some free slots for one-on-one teaching. So I do, for some people, weekly one-on-one teaching, and potentially if there are a few people who are at exactly the same stage, I can put together some groups and stuff like that. But anyway, get in touch if you're interested in any of this stuff, and I will leave it there for now, but not sure when, maybe in about a week's time, I will put out my next video, and in that I'm going to start actually doing some programming. So based on the setup from episode 0, I'm going to show you a really, really basic program and get us into the idea of what it means to actually write a program and run a program and see how it goes. So until then, I'll see you soon. I've been Mark Chi, and this is the Mark Chi School for kids who can't code good and want to do other things good too. See you soon.